It's our video for Unit 9, Day 2. So, yesterday we looked at basic probability of one event happening. Today we're going to look at two different kinds of probability of one event and then another happening, so two things happening in a row, and the probability of one event or another happening and how we calculate those probabilities. So, one extra wrinkle added on to what we did yesterday. So first thing we're going to look at is probability of one event happening and then another event happening. So this "and then" is going to be a keyword we'll use later. So for finding the probability of one event happening and then another event, we need to find out if these are independent or dependent events. So if two events are independent, one event occurring does not affect the probability of the second event occurring. So there's no correlation between them. One doesn't affect the other one. So they're independent of each other. One doesn't affect the probability of the other one happening. So if we want to find the probability of the two independent events happening, all we do is just multiply the two probabilities of those events. So here's an example question. What's the probability of rolling a 3 on a die and then rolling an even number? So there's our two events, and then is our keyword. Anytime we see "and then" on a probability question, it's going to mean that we multiply. So if we look at these two events, rolling a 3 on a die, that has a 1 out of 6 chance. So there's 1 3 on the die, 6 total sides. Even number, that has a 3 out of 6 chance. There's 3 even numbers on the die, 6 total sides. So to find the probability of rolling a 3 and then rolling an even number, these are independent of each other. So I multiply. So we get 3 over 36, and we can reduce that to 1 over 12. So that's an example of calculating one event and then two events happening in a row, one event and then another, when two events are independent. So now we're going to take a look at, as we have two dependent events, what dependent events look like. So first talk about what that means. If two events are dependent, the outcome of the first event, it does affect, it changes the probability of the second event. So it actually does have an impact. So if two events are dependent, whatever happens on the first event will actually change the probability of the second event happening. So we find the probability of these two happening one after the other, one and then the other, keyword "and then," you're still going to be multiplying. Still going to multiply the probability of the first one, but you're going to have to change probability of the second one. You're going to multiply it by a different probability from the second that's been adjusted. So I'll take you through an example of what that looks like. So these two events are dependent. And again, we see our keyword "and then." And just like with the example above, "and then" means we're going to be multiplying. That's whether it's dependent or independent, and then still means we're going to be multiplying. we look at the probabilities for each event. So the first event is taking out a Baby Ruth first. So there are 3 of those in the box and 10 total candies. The second one, taking out another Baby Ruth after eating the first one, we now have to adjust this. There's now only 2 Baby Ruth left in the box and only 9 total candies. Right, since we took one out, we had to adjust this top. There's 1 fewer Baby Ruth, and we have to adjust the bottom because there's 1 fewer in the total. But since it's and then, we're still going to be multiplying, so it's still going to be 3 over 10 times 2 over 9, which will give us 6 over 90. Again, we can reduce that to 1 over 15. So we're going to go through real quick, talk about how we can tell if 2 events are dependent or independent, and just go through these 2 examples here together. So the first pair of events, pulling a jack out of a deck of cards, replacing it, pulling another jack out of a deck of cards. Anytime we see this phrase, replacing it, that's a keyword that tells us it's independent. And the reason is once we replace it, we reset the probability so it doesn't change anything. We'd still have the same probability of pulling out a jack on the second try as on the first try because we reset everything. On the other hand, if you look at B, we have pulling the king of clubs out of a deck of cards, holding on to it, and then pulling a club out of the deck. And again, on both of these, we see that, and then holding on to it, now we have changed probability. This is a keyword for when we have 2 dependent events. So that's one way to be able to tell the difference between independent and dependent events. Mainly we're looking for, there's one event happening, change the probability of the other event happening. On the back here, there's some of these for you to try on your own. Right, so practice classifying whether dependent or independent, and also finding the probability. Remember that whenever it says and then, you're going to be multiplying. So next one we're looking at is one event or another event happening. So or probability. We're trying to find probably that one event or another event happens. And for this, we determine if these events are mutually exclusive or not. And not mutually exclusive is called overlapping. So events are either mutually exclusive or overlapping. So if 2 events are mutually exclusive, they have no common outcomes. And what that means is they cannot happen at the same time. So look at some examples here. Kind of explain what this means. Are these events mutually exclusive? So pulling 7 out of a deck of cards, pulling a face card out of a deck of cards. These are mutually exclusive. The reason is we can't pull a 7 out of the deck that is a face card. You can't do both on one draw. Look at the second one, pulling a 7 out of a deck of cards and pulling a card that's a suit of diamonds out of a deck of cards. This one is overlapping. The reason it's overlapping is we could pull out the 7 of diamonds. This card is both 7 and a diamond. So you can do both at the same time, so it's overlapping. Right, in C we have two events rolling a 6 on a die, rolling an odd number on a die. These are mutually exclusive. I can't do both on one roll. And last one, rolling a 6, rolling a number greater than 4. This one is overlapping. Again, if I roll 6, that's going to be both a 6 and it's going to be greater than 4. Right, so you can do both in one roll. So when we have two events that are mutually exclusive, to find the probability that one or the other will happen, all we do is just add up the probabilities of each event. So in this example, we have the one from above. We have pulling a 7 out of a deck of cards, pulling a face card out of a deck of cards. So pull 7 out of a deck of cards. There's 4 7s out of the deck of 52. And face cards, there are 16 out of a deck of 52. So I'm just going to add those up. That'll make 20 out of 52. Now we'll reduce to 5 over 13. And last thing, if two events are not mutually exclusive, so they're overlapping events, to find the probability that one or the other happens, we're still going to add the two probabilities, but then we're going to have to subtract the probability of the overlap or the intersection. So probability of both occurring at the same time. So we have a notation also you'll see used for that. If you have two events, A and B, we call it probability of A intersect B. This symbol right here is called intersection. the intersection means is the overlap, or it means both A and B at the same time. So we're going to use our example of the overlapping events from above. So we're pulling 7 out of a deck of cards, pulling a diamond out of a deck of cards. So sevens, there are 4 sevens in the deck of 52. For diamonds, there are 13 in the deck of 52. And there's overlap. There's one card that's both a 7 and a diamond, that's a 7 of diamonds. The reason we have to subtract it is because we counted it twice. We already counted it in one of the 4 sevens, we counted it as one of the 13 diamonds, so we have to subtract it so we don't double count it. So we have 4 and 13, 17 minus 1, 16 out of 52, which then reduces to 4 out of 13. One thing to point out before we move on is we have OR as another keyword. So we had and then as our keyword for multiplying, OR is our keyword for adding. The only difference between the two is if they are overlapping events, we have to subtract the overlap as well. On the next page, have some practice problems. We're doing the same thing, saying whether they're mutually exclusive or not, and finding the probability. In all of these, you'll see the word OR in there, which is telling you to add. Let's go ahead and try those practice problems. If you need any other videos or any other resources, you can search for independent-dependent events, mutually exclusive, and overlapping events.